All right, we got a little downtime in between all my conferences. I've got my Mountain Dew. I've got plenty of energy. Let's get all these videos done. All right, for the first one, we'll leave my pretty little mug down here in the corner. I know, you guys just miss me so much. So let's take a look at number one of the assessment review. A couple different things that we should talk about here. So it just says to graph this particular function. The form that this function is in, you've got to be able to recognize just by looking at this that this is in vertex form, which means I should be able to come up with the axis of symmetry and the vertex without doing any work really. Okay, so I got to find a pen down here. Let's grab, let's go with red. Okay, so first thing, let's take a look at the direction of opening. Is this thing going to open up, down, left, or right? Since it's a y equals, it's going to be either up or down. Since the leading coefficient, a, or basically this number here, 3, is positive, then this is going to open up. Alright, now the axis of symmetry, okay, this is going to be something that opens up somewhere through here. So if it's going to open up, then I know that my axis of symmetry is going to be a vertical line. So I got to start out with x equals. Remember that we always take the opposite of what we see here. I'm going to use the pen as kind of like a pointer. So x is equal to 2. Then we go ahead and we find the vertex. So if that's 2, remember it's hk. Here's h, here's k. So in this case then 2, -5. That's my vertex. So now let's go over here. So I'm to the right 2, and then I'm down 5. 1, 2, 3, 4, 5. So that's where my vertex is. So I'll label that with just a V for now. I'm going to grab a line from down here, make it dashed. We'll put some arrows on the end because that's what we need to do when coming up with our lines. So let's see, I need to draw this line. And okay, I guess I have to go through and do it again. Okay. So our line for the axis of symmetry is right there. So now I know I'm going to have a mirror image on each side. So back to the pen. Let's see, here's my, these are my, whoops, that doesn't make much sense there. I don't need lines for there. Alright, back to the pens. Back to the pen. Leave it a normal pen, red. Alright, so, see, look at that, you're learning how to use the smartboard at the same time. Alright, so we already have 2, -5. Since I don't have a lot of room, I'm not going to put all 5 points here. So I need to deal with where it's 1. And then back to 0, and we'll see how many values that gives me. So substitute a 1 into here. I get 1 minus 2, that's -1. -1 squared is +1. +1 times 3 is 3. 3 minus 5 is -2. And now you can check the arithmetic. I'm hoping that we know how to do the arithmetic for here. That's why I don't have all the work written out. Put a 0 in here. So I get 0 minus 2, that's -2. -2 squared, that's going to be 4. 3 times the 4 I got out of here, that's 12. 12 minus 5, that's going to give me 7. And you know what, based on the size of this graph, that's probably more than enough. So let's go here. So at 1, I'm down here at -2. At 0, 1, 2, 3, 4, 5, 6. Oh, how nice. It works perfectly. Alright, so now that I have these points, now I got to get the mirror image on the other side. And up here I'm 2 away, so I need to be 2 away there. Alright, and then we're going to try the best that I can to get this to actually look like a parabola. Okay, and this is exactly how you should. Okay, so there's my graph of the parabola. Don't forget this is my x-axis. We got to say this is my y-axis. Now we also talked about when is it increasing, when is it decreasing. What are the values of the domain? What are the values of the range? This is actually part of the first question if you look at the review packet. So if I look at the domain, writing with the pen is not as easy as it looks. Alright, so the domain, set of all x, such that x is, well, let's take a look here. If I'm way out here, Okay, so my x value is 1, 2, 3, 4, 5, -6. If I put a -6 in here, I'm going to be able to get a y value. If I put 25 in for x, I'm still going to get a y value. So it's a set of all x such that x is an element of the real numbers. Now I'm going to tell you right now, for parabolas, that's always going to be your domain. The range, though, is going to be different, and it's going to depend on what direction the parabola opens, how it looks. Okay, so here it's the set of all y such that, okay, so where is the value? Here's my vertex. That's the minimum I can be at. So y has to be greater than or equal to, and let's see, that is -5. So it has to be greater than or equal to -5. And then I close my cool little J letters, for lack of a better way to say it. Now I got to talk about where is this function increasing, where is it decreasing. So as I come from left to right, what happens? Well, here I am at, what's that value? 7. Then I drop down to -2. Then I drop down to a -5. So that means I'm decreasing the whole time. All right, so let's see. Let's try to just do this with using the font much smaller. There we go. So we're going to have decreasing, and then when is it increasing? Okay, so let's get back to the pens. It's going to decrease, and remember, it's going to be from way out here. Where's way out there? It's at infinity. Okay, so from infinity, less than x, less than, all right, well, where is it? Well, it's going to be where the axis of symmetry is. Okay, so the nice thing is I already have it as 2. Now, increasing, as I look from here, I'm at -5, then I'm up to 2, then I'm up to 7, then I'm up to who cares. So now it's going to be increasing from 2, less than x, less than, oops, infinity. Hopefully you noticed I made a small error here. How can I be from infinity? It has to be out here from -infinity to 2. From 2, then out to infinity, it's increasing. All right, so hopefully this helps with problem number 1. All right, bye.